This is a lesson for algebra for 1-3, day 3. What we're doing today is taking a little bit closer look at the function families, a little bit more detailed look. So looking at the linear functions, a basic of the linear functions look like this. You have f of x equals mx plus b. They can be increasing straight lines, decreasing straight lines, or constant straight lines. But this is your generic form of a linear function. A more detailed look, you could have your if your slope, the number that's in front of your x, your m here, if f of x equals mx plus b, this is that generic form. If your m is positive, it's going to be an increasing. If m is negative, it's going to be decreasing as you go from left to right. As your m gets bigger, the line gets steeper. Your b is your y-intercept, which is your starting value on your y-axis. So some examples, you have f of x equals x. That would be a straight line going up like that. Negative 2/3 x, because of the negative sign, it's going down. Notice that our y-intercept is +5, so that's why we have a point right there. It could be continuous or it could be discrete, depending on what we're talking about. If where x is an integer, that means it's going to be discrete, so it's going to be a dotted line. We have negative x plus 3, so it's going down, and it crosses the y-intercept right here because of that +3. We could also have a constant, which is just a going straight across if we don't have an x in there. Anytime you don't have an x and you just have y equals a number, there is no x value. It's just going to be a horizontal line going straight across. Taking a look at the next one. In the next one, we're looking at the exponential function family. For exponential function families, you're always going to have x as an exponent. So a times b to the x power. You're always going to have that x as an exponent. This could either be increasing or decreasing as we go from left to right. It's always going to be a single curve. You're always going to have a single curve when it's an exponential function. Taking a more detailed look at the exponential function, this is the generic form for it. F of x equals a times b to the x power. A is usually positive. In another chapter, we're going to talk about growth and decay. So that's going to be if your b value is greater than 0, it's going to go up. If b value is less than 0, it's going to go down. It's almost always going to go up. X is almost always an exponent. So you're always going to have that x as an exponent. Some examples, we might have something like this, f of x equals 1/2 to the x power minus 5. So that's a single curve that goes down. Here we have 2 to the x power, so that's going up. Notice it can be a discrete value as well. Our next one that we're talking about is the quadratic function family. In the quadratic function family, you're always going to have an exponent of a 2. That's going to make this U-shaped graph. Now, it might be an upside down U, all right, but we always have that U-shaped graph. Quadratic is a combination between increasing and decreasing. Where exponential was just that single curve, this has that increasing and decreasing aspect to it. With the quadratic function family, this is the generic form. We have a times x plus b times x plus c. That's the generic form for the quadratic function. If a is positive, the parabola is going to open up. These curves, this U-shaped graph is really called a parabola. So if a is positive, the parabola is going to open up like a U shape. If a is negative, the parabola is going to open down like an upside down U. If a is greater than 1, the parabola is going to be really skinny. If a is less than 1, it's going to be wider. And your c is going to be your y-intercept. We can have discrete with this as well. You see some examples down here. Our next one is the linear absolute value function family. So the linear absolute value function family always has these 2 straight up and down lines in them. That is the absolute value. Now that absolute value makes it form a V-shaped graph. It could be upside down, all right, but it is a combination of increasing and decreasing. With the linear absolute value function family, you're always going to get that V-shaped graph. Normally, if A is positive, the V is going to open upwards. If the A is negative, the V is going to open downwards. Notice that we have a negative here at -2. So that's why it opens downwards. All right. If the A value is greater than 1, it's going to be narrower. If the A is less than 1, it's going to be wider. We have a combination of maximums and minimums. Same thing that we had with the quadratic. We have a maximum. This would be an absolute maximum point. This would be an absolute minimum point. We have the same thing here, combination. This would be the absolute minimum. This would be the absolute maximum. Minimum is the lowest point. Maximum is the highest point of the graph. Last one that we're looking at is linear piecewise. Piecewise is your parts and pieces. This is the easiest one to pick out because it's all this jumbled up stuff. All right, your graph is really like a combination of things. It's a zigzag. It goes up and down and side to side. It goes all over the place. All right, it's that zigzag parts and pieces thing. With the piecewise function, we can't really graph these on the calculator, but it's going to be this zigzag of parts and pieces. And that is the lesson for today.